Given that 2 plus x to the power 5 plus 2 minus x to the power 5 is identical to a plus bx squared plus cx to the power 4, find the values of the constants a, b and c. Right, so let's think about the 2 plus x to the power 5 first of all. So let's expand that out. I would have 5c0, 2 to the power 5, x to the power 0, plus 5c1, 2 to the power 4, x to the power 1, plus 5c2, 2 cubed times x squared, plus 5c3 now, 2 squared times x cubed, plus 5c4, 2 to the power 1, x to the power 4, plus 5c5, 2 to the power 0, x to the power 5. Let's go through and simplify each of these. So 5c0 is 1, 2 to the power 5 is 32, x to the power 0 is 1. 5c1 is 5, 2 to the power 4 is 16, x to the power 1 is x. 5c2 is 10, 2 to the power 3 is 8, and then we have an x squared. 5c3 is 10, 2 squared is 4, times x cubed. 5c4 is 5, times 2 to the power 1 times x to the power 4, plus 5c5 is 1, 2 to the power 0 is 1, and then we have the x to the power 5. Each of those terms will now simplify, so the 1 times 32 times 1 is 32. The 5 times 16 times x is 80x. The 10 times 8 times x squared is 80x squared. The 10 times 4 times x cubed is 40x cubed. The 5 times 2 times x to the power 4 is 10x to the power 4. And then we have the x to the power 5 on the end there. So this is my 2 plus x to the power 5. Now what about the 2 minus x to the power 5? Well, I'm not going to start from scratch here because it is identical to what I just worked out previously, but the only difference is there's a minus x there. So if I just go back to my previous expansion and make each of these a minus x now, and I can hopefully see what the difference will be. So the first term, the minus x to the power 0, well, that minus will have no effect at all there. Anything to the power 0 is 1. The minus makes no difference at all. So my first term will still be 32. My second term will have a minus x here now though. So I will now have a minus 80x. My third term, the minus x when it is squared would now be a positive x squared. So actually that's going to be the same. The next term, when I had the minus x cubed, that's going to be minus x to the power 3. Minus x to the power 4, that's going to cancel out and be a positive. So actually my next term will be positive again. And my final term would be negative. I then need to add my two answers together. So 2 plus x to the power 5 plus 2 minus x to the power 5 will be 32 plus 32 is 64. The 80x and the minus 80x cancel out. The 80x squared plus 80x squared is 160x squared. The x cubed terms cancel out. I have 10x to the power 4 plus 10x to the power 4 is 20x to the power 4. And the x to the power 5 terms cancel out. So A is 64, B is 160, and C is 20. So that's my answer to part A. Part B. Using this substitution, y equals x squared, and my answer to part A, solve the equation 2 plus x to the power 5 plus 2 plus minus x to the power 5 is equal to 349. So this, which is this, is equal to 349. So I can replace all this with 349. And now I have a quadratic equation to solve. I'm just going to use that substitution. So if y equals x squared, then y squared would equal x to the power 4. So I could now say that 349 equals 64 plus 160y plus 20y squared. And if I now rearrange that equation, I get 20y squared plus 160y minus 285. If I now solve that equation, I find that y is going to equal 9 over 4. Let me just double check that actually. So let's use the quadratic, either the quadratic formula on this, or we can try and factorise, or obviously you've got your calculator to help you out with this. Just bear with me. Okay, so y is equal to 3 over 2 or minus 9.5. So therefore, x squared is going to equal either 3 over 2 or x squared is going to equal minus 9 over 5. Now I know obviously I can't square root that negative number, so I'm going to ignore that. I can square root here though. So square rooting both sides, x is going to be equal to plus or minus the square root of 3 over 2. And there we go.